Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I'd like to remind our listeners that your support means the world to us. If you're enjoying the show, please take a moment to rate us on your preferred podcast platform. It really helps us reach more developers like you.
Absolutely, Sheila. Your feedback not only motivates us, but also helps other developers discover our content. Now let's get started with today's episode, shall we?
Definitely. We're currently in Season 1, which is all about introducing decentralized systems. We've covered the basics of decentralization and peer-to-peer networks in our previous chapters. Today, we're starting Chapter 3, focusing on distributed hash tables, or DHTs. Our specific topic for this episode is concept and purpose of DHTs. To kick things off, I have a quiz question for our listeners. In which popular peer-to-peer file-sharing protocol are DHTs commonly used?
Ooh, that's an intriguing question, Sheila. It really makes you think about the practical applications of DHTs in the real world. Without giving away the answer, I think our listeners will find it interesting to consider how DHTs might be used in file-sharing systems. It's a great way to connect our theoretical discussion with something many people have likely encountered, even if they didn't know the underlying technology.
Absolutely, Victor. Now, before we dive deeper, could you give us a basic definition of what a distributed hash table is?
Certainly. A distributed hash table, or DHT, is a decentralized system for storing and retrieving data in a network. It's similar to a regular hash table that you might use in programming, which is a data structure that stores key-value pairs for quick lookup. But instead of existing on a single machine, it's spread across many nodes in a peer-to-peer network. Each node in a DHT is responsible for storing a portion of the overall data.
That's interesting. So it's like taking a regular hash table and stretching it across multiple computers. Can you explain why we'd want to do that?
Great question. Let's look at the purpose behind this approach. The main reason for using DHTs is to provide a way to store and retrieve data in a decentralized manner. This has several advantages. First, it improves scalability because you can add more nodes to the network to increase storage capacity and performance. Second, it enhances reliability since there's no single point of failure. If one node goes down, the data is still available from other nodes. Lastly, it provides a level of anonymity and censorship resistance, as there's no central authority controlling the data.
I see. So, if I understand correctly, it's like having a phone book that's torn into pieces and distributed among a group of people. Each person is responsible for a certain section, but together they can still look up any number in the entire book. Is that a fair analogy?
That's an excellent analogy, Sheila. It captures the distributed nature of DHTs perfectly. To extend that analogy a bit, imagine if someone wanted to find a specific phone number. Instead of going to a central office, they'd ask around until they find the person holding the relevant section of the phone book. This person-to-person communication is similar to how nodes in a DHT network interact to locate and retrieve data.
Thanks, Victor. That really helps visualize the concept. Can you tell us a bit about the history of DHTs? When and why were they first developed?
Certainly. DHTs were first conceived in the early 2000s as researchers were looking for ways to create more efficient and robust peer-to-peer systems. One of the earliest and most influential DHT designs was Cord, developed by researchers at MIT in 2001. This was followed by other designs like Pastry and Kademlia. The goal was to overcome limitations of earlier P2P systems, which often relied on central servers for coordination or used inefficient flooding techniques for data lookup.
That's fascinating. It seems like DHTs were a significant step forward in P2P technology. Now, you mentioned earlier that DHTs are used in file sharing protocols. Can you give us some examples of real-world applications of DHTs?
Absolutely. One of the most well-known applications of DHTs is in the BitTorrent protocol, which uses them for peer discovery without relying on a central tracker. DHTs are also used in some decentralized storage systems like IPFS, Interplanetary File System. They're even used in some cryptocurrency networks for peer discovery and routing. Outside of pure tech applications, DHTs have been proposed for use in distributed databases, content delivery networks, and even in some Internet of Things, IoT scenarios.
Wow, that's a wide range of applications. It seems like DHTs are really versatile. Are there any common misunderstandings or pitfalls that developers should be aware of when working with DHTs?
Great point, Sheila. One common misunderstanding is that DHTs provide instant consistency, like a centralized database. In reality, due to their distributed nature, DHTs typically provide eventual consistency, meaning it might take some time for updates to propagate through the network. Another pitfall is underestimating the complexity of implementing a DHT correctly, especially when it comes to handling node churn. That is, nodes joining and leaving the network frequently. It's also important to consider security implications, as DHTs can be vulnerable to certain types of attacks if not properly designed.
Those are important considerations, Victor. To help our listeners remember the key points about DHTs, could you summarize the main advantages of using them?
Certainly. The key advantages of DHTs can be summarized with the acronym SCALE, S, scalability, easy to grow by adding more nodes. C, consistency, provides eventual consistency across the network. A, availability, high availability due to data replication. L, load balancing, distributes storage and lookup load across nodes. E, efficiency, enables efficient data lookup in large networks.
That's a great mnemonic, Victor. Now, I think it's time to reveal the answer to our quiz question. The popular peer-to-peer file sharing protocol that commonly uses DHTs is BitTorrent. DHTs play a crucial role in BitTorrent's decentralized approach to file sharing.
Exactly right, Sheila. And that ties back nicely to our discussion of real-world applications of DHTs.
Indeed, it does. Well, that brings us to the end of today's episode. We've covered the concept and purpose of distributed hash tables, their history, advantages, and some real-world applications. In our next episode, we'll dive deeper into the basic operations of DHTs. Thank you for listening, everyone.
Yes, thank you all. And remember, if you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy coding.